Here's some examples of that single displacement reaction. So we have a bar of zinc. So it's talking about elemental zinc, just zinc all by itself, immersed in a solution of silver nitrate. So if it's a solution, that means it dissolves in water. So we would show the silver and nitrate ions broken up. Silver +1, nitrates -1. When those combine, the zinc is going to try and combine with our nitrate to make zinc nitrate. Well, if you know your solubility rules, all nitrates are soluble, so our zinc nitrate is going to break up into zinc ions, Zn+2, and nitrate ions, NO3 -1. So if you have Zn+2 with nitrate -1, we're going to need 2 nitrates to balance out the charge from that zinc. Then the silver is going to be all by itself. It gets kicked out. Zinc used to be the element on the left. It turned into part of a compound on the right. The silver used to be part of a compound on the left. It turned into an element on the right. Well, you have to balance overall. If we have 2 nitrates on the right, we need 2 nitrates on the left. Well, if you have 2 NO3 minuses, you would need 2 silver pluses to keep the charge balance on the left-hand side. And now if you have 2 silvers on the left, you're going to need 2 silvers on the right. Well, those nitrates end up being spectator ions, right? They end up canceling out and going away. So in the end, you have zinc being added to 2 silver ions. The products, zinc ions and 2 silver atoms, neutral. Your charge should make sense along the way of who's gaining, who's losing, how many. So if you were to compare left and right hand sides, the zinc on the left is elemental zinc, not part of a compound, does not have a charge, neutral. Then it goes over to +2 on the right. So when it goes from here to here, this guy is losing 2 electrons. Well, where did they go? They can't just vanish into thin air. They went to the silver. On the left-hand side, we have 2 Ag pluses. On the right-hand side, we're talking about elemental silver, not part of a compound, all by itself, neutral. So to go from +1 to 0, it has to gain an electron. There's 2 silvers. It happens twice. These reactions here can be a little bit tricky when you have a metal being added to a strong acid. A lot of times when that happens, metal plus strong acid, it's kind of normal to see some bubbling happen. What often happens when you're adding metals to strong acids, you'll get some kind of metal ion solution, an oxide gas, and water forming. So these guys, copper being added to dilute nitric acid. Dilute does not impact the fact that nitric acid is a strong acid. Strong means does it break up into ions or not. Concentrated and dilute, it's talking about the molarity of the substance, something completely different. So don't get messed up by that guy. Nitric acid is on our strong acid list, so we show it broken up into ions here, right? And then you form your metal ion solution. So in this case, it's copper nitrate. Some of those nitrates end up getting canceled out. which is why if you're wondering, wait, how could we have 8 H pluses and only 2 NO3 minuses for our nitric acid? Like, why aren't there the same number of H's as NO3?